Hey everyone, this is Darshan Senthil and I'm coming at you today with yet another math video. I'm making them at a pretty fast rate now since I've got time, and this one is going to be about direct variation, which somewhat comes under the chapter of linear equations. So what is direct variation, you may ask? Where it's basically when one quantity varies directly in a direct proportion with another. So basically, as one thing goes up, another thing goes up, and they go up in a fixed proportion. So like if I go up like this, then the other thing goes up like this, and it goes in this fixed ratio, something like that. If you follow me so far? Okay. So yeah, basically as one quantity goes up, the other goes up as well in that fixed ratio. So that's what it is. And then let me just give you some examples of what direct variation may look like, some real life examples. And for instance, as medical availability increases, the life expectancy increases. So yeah, as you have more access to medicines and stuff like that, you're expected to live longer. And as the amount of exercise you do increases, your fitness increases. The more fit you are, the more stamina you have and stuff like that. And as the amount of time you spend studying increases, the more your GPA increases, or your grades, higher your grades are, whatever. So these are just some examples of how direct variation would work. So it's basically, like I just said, it's when one quantity goes up and the other quantity goes up as well. It's that simple. And this is just a part of linear equations because, you know, we can graph this stuff and all that. And I'm just going to show you how you would put this in an equation and stuff in just a minute. So, what do you think is the equation we could use to model direct variation? Well, it's actually going to be this. Y is equal to kx. So this is the equation we could use to model direct variation. It's not very complicating to explain to. I'm just going to do a little bit of a rundown for you and tell you what it is. So again, this is y is going to be your y value as usual, and x is going to be your x value. Just the same thing as we've done in everything we've done about everything else we've covered so far. And this thing is the only thing that changes. It's basically going to be your constant of variation. Your constant of variation. And this is something that will determine how much your equation will vary by. So if you have a higher number here, that means the amount of variation in your equation will be a little more drastic. That's it. This is also kind of like your slope of sorts. So yeah, you could also call it your slope. Like in a like if you compare this to, say, a linear equation, there's actually very little difference between these two. And what do you think is the only big difference between these two? Now that we're on that, what do you think is the big difference between these two? There's the b, right? You don't have a b over here, but you have a b over there. So basically, a direct variation equation is basically the same thing as a linear equation, except without the b. You will have no y-intercept in a direct variation equation. So what does that tell you? If there's no y-intercept, what does that tell you about the equation? So what point will it have to go through when x is equal to 0 if you have a direct variation equation? It'll have to go through 0, 0, right? So just note this thing down. So all direct variation equations will always go through this point 0, 0. They will always go through this point. So if you want to write that down, then it's a useful note to have. But just keep that in mind, that if you've got a direct variation equation, it will always go through 0, 0. If it doesn't, then it's either not direct variation or you're doing something wrong. So if we were to graph a direct variation equation, it would look something like this, or forgive me for the sloppiness of this, then, or something like this. Again, the direction of the line is totally dependent on your k value. Could even go like this. Whoopsies. This. However it went, it will always go through this point right here. That point, it will always go through there. So just keep that in mind. It's something that you should know. So let's just do a few problems now that we've got this concept. Right, so for this first example, we're just gonna write and graph a direct variation equation that has this pair as a solution. So it's the same thing we've done in stuff like linear equations. We're just gonna do the same thing for direct variation, so you see how it's done. So off to the side, I'm just gonna write the equation here. That's y is equal to kx, just for our reference, so we can look back there whenever we need to. And now I'm just gonna sort of do one of these for you. So again, so we're just gonna graph an equation for a line that has this point on it. So if it has the given ordered pair as a solution, that means that this point is on the line that this graph represents. So we're just gonna find a line that has this as a solution. Okay. So for that, all we're gonna have to do is plug this back in here. That's all we're gonna do. It's the same thing as we did for linear equations. We're just gonna plug this back in there. So let's just do that. So 6 is gonna be equal to 2k. Remember, there is no b, so this is pretty much gonna be our last step. And then we're just gonna solve by 2 by 2, and then k is gonna be equal to 3. And then now it's asking us to graph. So how would we graph? All we'd have to do is put this thing back into this equation now. And sorry, wait. Oh yeah, we need to write the equation. We haven't written the equation yet. Sorry, my mistake. So to write the equation, all we're gonna do is plug this thing back into this. So we're gonna plug this k value back in here to write our final equation. And that is just gonna look something like this. Y equals 3x. That's all we've got. That's all that we need to do here. This is our final equation. So now let's graph it. Again, you can do this in your graphing calculator if you want. It saves a lot of time, but it's important that you know to do it by hand as well. So I'm just going to do it by hand over here. So you just see how it's done the manual way. So once again, you can plug in some value for y and then you get something for x. So let's just try that. So if we plug in 1 for y, we're gonna get 3 for x. So that's so remember, first up 0, 0 is gonna be our point, so keep that in mind. And then we move 1 up for y and 3 across for x, and then we just continue that way. So if we put 2 here, we get 6. So we go 1 more up and 1, 2, 3 across. So that's 1, 2, 3, 4, 5, and 6. So we could stop here, but I'm just gonna do a few more. We're gonna go negative now since we can't go any further here. So we plugged in -1, we get -3. So -1, so -1, 1, -1, -2, -3, and then again negative, what's that, 2, we get -6. -1, -1, -2, -3. So yeah, that's all we need. And now we would draw our line. Just place that properly. Yep, that's that. See, this is not, this is not like 100% accurate, but it just gives you a good idea of what this should look like. So I'm a bit of a perfectionist. Oh, that looks much better. So yeah, that's basically what this should look like. A sort of line like that. And then we could also look for this point 2,6, and if you notice 2,6 is a point on the line. So this line, this is an answer as well. You can always check that up, check your equation to see if this given point is on it, and if it's there, then you've pretty much, then you got it completely right. You got it right that way. So yep, that's for the first example. And now we're gonna do this one as well. I'm just gonna do it in a different color so that you don't get confused, and I'll do that in yellow. Okay, so for this thing we're just gonna do it in yellow. I'm sorry if you can't see that, but you probably see better down here. We're just gonna do it down there, and then the same thing, we're just gonna plug this in there first up, and we're gonna start just sort of find our k value. So then 12 is gonna be equal to -3 times k. So now we're gonna divide both sides by -3. That's gonna give us -4 will be equal to k. Okay, and then now we're gonna put this k back into our original equation, and we're gonna find our proper equation for this particular problem. So that will be y is equal to -4 times k, for times x, for beg your pardon. That is gonna be what our equation is. And for plotting the points for this graph, I'm gonna put the points in a different color, but I'll draw the line in the same color. So okay, just so you can see the points better. So -3 and 12. So let's start by inputting some values in here. So we put in 1, we'd get -4, so that's a point. And oh yeah, once again 0, 0 is gonna be a point. So 1 times 1 and -1, 2, 3, 4, that's gonna be a point. Then put in 2, we're gonna get -8, but that's not gonna be on the graph, so we're just gonna stop at -1. And if we put -1 in here, -1 times -4 is gonna give you +4. So if you drop down 1, and you're gonna go 1, 2, 3, 4 across. So that's those are our 2 points, 3 points, beg your pardon. And if we could go further than that, but this graph isn't big enough for it, so we're just gonna stop there. And we're gonna draw our line this time. Now, okay. So line's gonna be in yellow. Just the points are in red because you won't be able to see them very well if they were yellow. Okay, that one I think I've got it pretty well. Okay, I'm not sure how well you can see that, but you get the picture. So yep, that's how you would graph this equation as well. And yeah, that's pretty much the end of that. And I'm gonna leave these two for you to do if you want some practice, and yeah, you can try those out on your own. You can pause this video if you like and see if you can apply what you've just learned in those. So yep, that's it for this, and I'm just gonna move on to the next example now. Right, for this example, we've just been given a table, and we've been asked to determine whether this table shows direct variation or not. And also, they've said that if it does, we should write an equation relating them. So it's nothing that we haven't seen before, but we're just taking this one step higher. So what do we do for the previous equation when we are given a coordinate and asked to write a direct variation equation for it? So we just put our equation, I'm just gonna put it up there. We just plugged in our y value and plugged in our x value and solved for k, right? That's what we did. So we could also, in theory, we could also do that over here, but there is a much easier way to see whether this would work or not. And that is, for that I'm gonna have to do the following here. we're going to need to twist the equation slightly to make it work in our favor. So if y over k, y is going to be equal to k times x, then shouldn't y over x also be equal to k? That can be true too, right? Because after all, we're just simply manipulating the equation slightly. This should be true, right? And if this were to be true, if we were to divide any y value by the x value, we should get our k value, right? And that is, yeah, that's what should happen here. And then, if we divided all of these values, all of them, if we divided all of these with each other, and we got the same k value, then we could safely say that this table represented direct variation. So you got me? So we're just gonna simply divide these values by each other, or to be more specific, our y by our x, and then we're gonna see if they have the same constant of equation, and then if that is there, then we've done the problem. So I'm just gonna pull out the calculator here. So let's get started. So first up is -1 divided by 3. So 1 divided by 3, which is going to be equal to -1/3, and yeah, it's going to be -1/3. Just keep that in mind, and maybe you can write it down here. Just push that aside. So -1/3. Just pull that back in, and -2 by 6. 2 by 6. That's also -1/3. Just it matches up with our first one. And then we're just going to do the next one, which is -3. Wait, sorry. -3 by 9, which is again -1/3. And then we're going to do this again, and -4 by 12. It's going to be again -1/3. We're almost there, just one more to go. So keep in mind that you should test each and every one of these, not just like the first 3 or something and assume it to be correct, because sometimes the problem might be slightly twisted. So all the first 4 may be correct, but the last one could be wrong. So just make sure you test everything in advance. Just make sure you test everything. And then for the last one, yeah, -5 over 15, and that's again -1/3. So by this testing, we can conclude that -1/3 is our k, so all of them work out. So -1/3 is going to be our k value. So we could plug this back in, and now it's going to ask us for the final equation. So we can pick what we've got over here and plug it back in, and y is going to be equal to -1/3 times k. You could also write this as y is equal to -k over 3. That would be perfectly fine as well. Or maybe you could put the negative over there or something. That's perfectly okay. But this thing just looks a little bit more easily distinguishable as the k and the... oh dang, sorry, that's my mistake. It's not that, it's x. So -1/3 x. You could write this like this, or you could write y is equal to -x over 3. So 1/3 is the k, -1/3 is the k, and the x we're supposed to put here, not the k. So this is our final equation, and yep, I hope you found that's how you would solve this kind of a problem. So now let's try this one and see how it would work. Again, we're going to do the same thing. Divide these, divide these, divide these, and see what happens. Just going to pull the calculator up here. So first we're going to do 7 divided by 1. It's going to be 7. And then we're going to do 9 divided by 2, which is 4.5. But they don't match, so hence this thing, you could say right away that this does not represent direct variation. These do not work out, so not direct variation. Oopsies. and this is direct variation. Not sure if you can read that, but yeah, you get the idea. So this is basically how you would solve this kind of an example. If you're just given a table, you would just simply divide these values by each other, and then you would determine whether it's direct variation or not. So that's how you would do it, and you can see why this is easier than plugging it back in, because now all you have to do is simply, maybe you pull out a calculator, you would just simply divide this, divide this, divide this, divide this, and divide this, and this would take you very little time. It would take you about maybe 20 seconds if you were, maybe, yeah, 20 seconds tops if it really took you a while to type stuff in your calculator. But other than that, this should finish very quickly, and that's how you would be able to quickly solve and tell whether this is direct variation or not. So yep, thanks for watching this video. I hope you enjoyed it, and direct variation is something that's really easy, I feel, just a continuation to the linear equations chapter. And I hope you found the video helpful, and I hope it helps you pass your next test if you have one. So yep, thanks for watching.